AB is given velocity. Okay, I'll make it the total problem. Let's the moving rod, even the rod AB is also having resistance, no? With equal resistance are joined at two rods AB and CD, each of mass M and resistance R. Let me take it in this way. This is the E, the EMF. I'll make problem in this way, so that it'll be easy for you to even the other rod will also start moving. Now, why it will start moving is what we have to give explanation. The resistance R. The three resistors I'll replace with a resistance 3R, R by 3, as they are parallel. This is the rod AB, this is the rod CD. I think this will be sufficient, and everywhere the magnetic field is into the plane. May make problem, simplify like this. Now, as the rod starts moving, as the rod AB is given velocity V, it is given velocity V, no? So let V be the velocity of the rod at any time t. No, I think rod AB, okay. Rod AB is pulled by a constant velocity V. The velocity of the rod will be constant. Let EMF induced in the rod be AB. Now, will there be any current will flow? Yes, there will be a flow of current. So here current, let me take I2. You can take any symbol. Let me choose this as I2. Then this current I2, it will branch. A part of current will flow here. And the remaining part of current has to come and flow here. Okay, the remaining current has to flow here. So now when this current starts flowing across the rod CD, a force will act on it. BIL force. Will say the same current I2 will flow. No, it will branch here. No. So let's take this current as I naught. Here is saying I, let me call I naught. Later on I'll come back to the problem. So the here current, let it be I1. So because of that, BI1L force will act. Because of this BI1L force, the rod starts accelerating. Because of that acceleration, it will also acquire a velocity V. Let the velocity of this be V1. If you can make up things, it'll be easy for you now. Why do the rod CD should move towards right? Because of force BI1L, and it will accelerate. Okay, let the EMF induced across the rod, let it be E1. Okay, this is the basic setup. If a student can bring it here, as he can later part he can manage. Okay, now let's write the loop equation. E minus I2R minus I naught R by 3. There's a one loop equation. Equation 1. Similarly, E1 plus I1 R1 minus I naught R by 3. This is the equation 2. Yeah, we have taken this much, no? What is our question? Find the current I, means this current through the rod EF. Later on, I'll replace it. Let me calculate first I naught here. Velocity of the rod CD as a function. Is asking to get expression for current through the branch EF and the velocity of the rod CD, that is V1. That's what we have to try here. So let's write a loop equation, KCL. I2 is equal to I naught plus I1. Solving 1, 2, 3. So we should get expression for the velocity, the current. First we have to calculate I1 and I2. Once you know I1 and I2, then we can get the I naught. Okay, let me begin here. So what is I2 is equal to E minus, what is E? E is BLV. E minus I naught R by 3. This is equal to I naught. I1 is equal to E1. Solving, and what is E is equal to? E plus E1 equal to I naught by R. Sorry. All divided by R. E by R, E1 by R. So this will be, what is E is equal to? E should be equal to BLV. So this will be 2 by 3, phi I by 3, phi I naught by 3. So this, I think, one equation what we have, I naught is equal to 3 by phi R. Check once calculation. I think I'm right. Okay, this call equation 4. This value of 4 you substitute in 1 and 2, you'll get I1 and I2. Put 4 in 1, we'll get I2. I solved it. So I'm getting, this is V minus 4V1. Similarly, put 4 into I1 is equal to 4BL this is some BL 5R 4V1 minus V. Anybody wants, you can check it. Okay, I got I1 and I2. After getting I1 and I2, so what is the unknown thing now? Current I. Okay, these are I1 and I2. I'll substitute I1 and I2 here, but I0 and these two are unknown, no? And I'll substitute I0 also. So this will be the equation. What number will come? 4. Okay, this is 5, 6. So substitute 4, 5, 6. Here we'll get expression for V1. Then after getting V1, then what will happen? We can get the I0. Then what is the current in this? Should be I0 by 3. Am I right?
Sir.
I'll check the answer, whether it's available or not.
We can also use mdv1 by dt equal to bi1l.
Choice is yours.
But how did you get the answer without that?
I'm just proposing idea. What is asking? Find the velocity of the rod CD as a function of time. No, okay, as a function of time, we have to integrate. We have to go for ma equal to bi1l, and we have to solve it.
Sir, from these three equations, you found out 4 variables. You found out v1, you found out I1, I2, I0. 4 variables you found out.
What is this? I'll substitute I0 here. I'll substitute I2. Then I'll substitute I1. I'll get the expression for V1, no, as a function
Sir,
of
maybe there is somewhere some calculation mistake, but from three equations, how can we get four answers?
Here we are.
Four
Here you
values.
eliminated I naught R by 3, sir. So that's the reason you found out, sir. Subtracting first and second equation and equating in third one, you got the answer, sir. So I naught got cancelled in that.
Yeah, this I not see like any problem with this?
No, sir. Correct.
No, sir. Correct.
No, that's what like I just tried it this one.
What is the answer, sir?
Current through EF is if telling BL, okay, current through this one. That I is what I'll write it. That here only let me write it. Check it once. Will you get this one? V plus V1. V1 is unknown thing. Again, V1 has to be determined. In terms of V1, he has brought it. Again, V1 is what will come. So, and V1 will be is equal to V by 4, 1 minus.
That is what I was telling, sir. To get the expression of V1, we need force equal to BIL, that MA equal to BIL, that equation. With that only we can get all the answers.
Okay, no. Okay, I1, okay, we have to introduce here, no? We can't get, no? 4, 6 if I substitute there. 4, 5, 6 in 3.
Whatever we do, sir, we can't get. We'll get either in terms of V1 or some other
Sir?
variable. We need this equation to get the answer.
I thought, okay. Okay, this again now. Okay, let me. BL, okay, this will be BL 5R 4V1 minus V. Okay, this I think we have to solve. dV1 by okay, you mean to say this much I should do? Huh?
Yes,
0,
sir.
yeah, 0 to V1, 0 to T. Okay, then no, yeah, then only exponentially will come here. Where that lambda he has given answer. Yeah, I think we'll end up. I think first we can. Yes, see, why we have to do this one is for if I write it here. So what to write? I1 is a problem, no? That's why we have to do all this particular method. The background is what we have to cover it. So anyway, like we have to calculate the current through this particular thing, no? So that will be audible. By 3, if you do it, it will be okay. It can be asked in advance, I think, not that big. Huh?